In this fast-moving society, people are under a lot of stress. Heart diseases are getting closer to us. The most critical health worry is atrial fibrillation. What exactly is atrial fibrillation? Well, in general, a common way to detect heart problem is to use electrocardiogram. There are P, Q, R, S, and T complex wave. And in atrial fibrillation, there are three cases. First, the absence of P wave. Second, the irregularity of P wave. Third, QRS complex should be narrow. But why are we doing this project? Heart plays an important role in human being. It is one of the life-sustaining organs. Therefore, if there is a problem with your heart, it can lead to complication or even death. According to the statistics from Ministry of Health and Welfare in 2018, stroke is the third of 10 causes of death in Taiwan. There are 1 in 6 people suffering from stroke, which is caused by atrial fibrillation, and the stroke caused by atrial fibrillation is 5 times as many as stroke caused by comet. However, it is unobvious at the first stage to detect atrial fibrillation. It spends a lot of time and money to detect the disorder. It is tiring. When we notice it, it's too late. On the other hand, as the medical resources are everywhere, we can obtain medicine or detect diseases easily due to the shared payment. According to the latest statistics, the National Health Insurance lost up to 12.4 billion NTD, and in the United States, the annual expenditure is about 6.6 billion USD, and in Europe, it is approximately 13.5 billion euro. So we are doing this research to solve this problem. But how do we make it? First, we use data from Physionet, which is an organization providing open data from clinical institutions. The data is variable length, so we made it 30 seconds to be processed. For those within 30 seconds, we copy the whole data in the back to fulfill the length, and we cut the data over 30 seconds to make more data. After the preprocessing, we got 11,505 data. Then we split it into the proportion of 5:3 for training, validation, and test data. We feed the data into our proposed one-dimensional CNN model, and the data is composed of the amplitude of electrocardiogram. These are two parts in convolutional neural network, convolutional layer and pooling layer. In convolutional layer, the kernel will slide over data and extract features, while in pooling layer, it helps us to reduce the dimensionality and training parameters. Finally, these output nodes will be flattened into one-dimensional array, then send it to fully connected layers, and get the possibilities from each category. In two-dimensional CNN, we transform the electrocardiogram data to spectrogram and do the same thing as in one-dimensional CNN. Lastly, our future plan. We hope we could combine our algorithm with wearable devices, making use of our result to detect if there is any possibility to have heart diseases. We would like to discover your diseases earlier to save doctors time for those who is really in need.